Lesson 6-2. Our learning target today is I can solve a system of equations by substitution. Our essential question is how do you solve a system of equations using substitution? So the essential question today is focusing on the steps for using substitution. Our first example says use substitution to solve the system of equations. 5y plus 2x equals -1, and y equals 3x plus 10. Remember, we talked about yesterday what you look for to substitute in your equation. You look for a variable all alone. Remember, a variable is a letter. And when I say all alone, that means it's the only thing on that side of the equation. So there can't be any other numbers or letters or operations with it. It has to be just the letter X or just the letter Y on one side of an equal sign. So in this system of equations, the only variable all alone is Y in the second equation. Now it has the same value as 3x plus 10. So we are going to replace the letter y with 3x plus 10. That we do in the other equation. So I'm writing down the first equation, and where the letter y is, I'm going to replace it with 3x plus 10. Today, what's a little different is instead of another rectangle, notice I put it in parentheses when I replaced it. The reason that I did that is because there's a 5 in front of that y that I'm substituting for, and that 5 needs to be distributed. So 5 times 3x is 15x, and then 5 times 10 is 50. So here is the equation that we are solving. So this equation has like terms 15x and 2x that are on the same side. So I add those two together. They are same side like terms. And then I can finish solving my equation for x by subtracting the 50, because that's the inverse of adding 50. So then 17x equals -51. And then I can divide by 17. And that will leave me with x equals -3. So the x-coordinate is -3. I write that one first in my ordered pair. Remember, these are always going to be intersecting lines with one solution. And then I go back up to my rectangle. And this equation said y equals 3 times x plus 10. So 3 times x. Remember, x we found right here is -3. So we're substituting that in. So 3 times -3 plus 10. And now I just use PEMDAS to simplify this. 3 times -3 is -9 plus 10 is 1. So the y coordinate is 1. So these two equations represent lines that intersect at the point -3, 1. My next example, this one, the letter that is all alone is the letter x on the first equation. It's equal in value to 2y plus 1. So where the other x is, I replace it with 2y plus 1. There's a 3 in front of the x. A -4y equals 7 after it. And then distribute that 3 and solve it. 3 times 2y is 6y, plus 3 times 1 is 3. -4y equals 7. The like terms on the same side this time, 6y minus 4y. 6y minus 4y is 2y. So 2y plus 3 equals 7. And then the inverse of adding 3 is subtracting 3. So I subtract 3 on both sides. So 2y equals 4. And then I need to divide by 2 on both sides. So y equals 2. So for this system, we found the y-coordinate first. So the y-coordinate is 2. I bring that back up to my rectangle, and my equation said x equals 2 times y. So 2 times 2. Y, right here at the bottom, y is 2. So there's where I'm putting it. So 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. So the x-coordinate is 5. So these lines intersect. There's one solution, and that solution is 5, 2. Example number 3. The variable by itself is x. It is equal in value to 4y minus 6 this time. So I need to substitute into the top equation. I replace the letter x with 4y minus 6. In front of x this time is a 3. After it, plus 5y equals negative 1. Distribute the 3 to get 12y minus 18. And then plus 5y equals negative 1. The like terms on the same side. 12y plus 5y is 17y minus 18 equals negative 1. The inverse of adding 18, or subtracting 18, sorry, is adding 18. So add 18 on both sides. 17y then equals 17. And if I divide by 17, y equals 1. So the y-coordinate is 1. Bring that y-coordinate back up to the rectangle. X equals 4 times y. And y is 1 this time, minus 6. 4 times 1 is 4, minus 6 is negative 2. So negative 2, 1, and again, they're intersecting. That is the one solution. Negative 2, 1. Next example, this time the letter y is by itself. It's equal in value to 4x minus 1. So I'm going to rewrite the top equation. We are replacing the letter y with 4x minus 1. 9x minus 2 goes in front of my parentheses, and then equals 7 goes after. This one's a little bit tricky because distributing, you need to think about this 2 as being a negative 2. So it would be negative 2 times 4x is negative 8x, and negative 2 times negative 1 is positive 2. Then I have my 9x, and my equals 7. So 9x minus 8x is just 1x. So x plus 2 equals 7. Remember, when it's 1x, you don't have to write the 1 here in front. If you want to, you can, but you don't have to write it there. So I'm not going to write it because then it saves me a step. So if I subtract 2 on both sides, x equals 5. So the x-coordinate is 5. Go back up to the rectangle. Y equals 4 times x, which is 5, minus 1. So this value for x is right here. 4 times 5 is 20, minus 1 is 19. So these lines intersect at 5, 19. So they're intersecting. One solution again. They cross at 5 and 19. And that was our last example. So hopefully, after 4 examples, you understand how to solve these systems when you have to use the distributive property. On your practice work, some of them will require you to use the distributive property and some of them will not. So just be careful.